Okay, so I've got an hour. I'm gonna do my very best to try to get through this because I know it's Friday, short day. So, and if you have your form signed and I'm done early, you guys can go. So there's benefit to those of you who got your form. So, okay, let's get started here. Today's topic is about function operations, and before I get maybe more into the notes, what are the four main operations? This sounds a dumb question, but what are the four operations in that? Yeah, that's it, yeah. So what we're going to talk about today is, you know how you guys have learned in the past how to add numbers, right? When you were in grade 1, you learned 1 plus 3, 7 plus 9, right? And then we built that up to the next level, which was, what if I ask you to add 3x plus 2x, right? You learned how to add variables to each other, right? Well, we're going to do a very similar concept today, only now we're going to add functions to each other, or subtract functions from each other, or multiply or divide. Does that make sense? So it's kind of a natural continuation. We start with just numbers. We build numbers up to letters, right? We turn letters into graphs and equations, and now we're going to do the same process we've been doing all along, only now with graphs and equations. So with that as kind of your clue, here's my first little question for you. I've actually got 3 graphs on here. Can anyone pick out how they're related to each other? Do you see the trick I'm going for? Take a second just to consider that. Remember, the topic is operations, right? We're going to add, subtract, multiply, and divide graphs from each other. Two of them are going to get combined to make the third one. Which 2 are being combined to make the third? Yeah, blue and green add to make red. Can you guys see this now? Right? In a way, what we're going to talk about today is the idea that f of x added to g of x is equal to h of x. You guys remember this notation, f bracket x? That just means like, it's just another variable, another notation to describe your graph or your equation, and we use different letters to kind of keep them separated. Have we talked about that before? You guys have seen that? Okay. Right? Or another way of looking at it is if f of x is 2x plus 1, and if g of x is x squared, then isn't that x squared plus 2x plus 1? So that's kind of the preamble to our day. Like I said, we're going to talk about how to add, subtract, multiply, divide operations. So, I mean, here's some basic ideas, right? If you want to sum them, you can just take 2 of them and add them together. This is what I need you guys to know. This is an alternate notation. If I write f plus g in brackets and then x, that's the same thing as just adding them separately, if that makes sense. It's just another way of writing it. So if you ever see f minus gx on a worksheet or in a textbook or on your assignment, this notation just means take the one graph and subtract the other graph. Fair enough? Let's do an example. Let's sketch 2x minus 1, x minus 2, and then let's try to figure out what adding them together would give us. I might rush just naturally because I know it's a Friday. Please slow me down if I need to, okay? Like we don't have to rush too much, but I do want to try to finish this today. So if you guys have colors, it sure helps. If you don't have colors, then do something. But I'm going to go with purple for 2x minus 1. And maybe try not to use your graphing calculator because it's going to slow you down. If you know what you're doing, but like on a linear graph like this, you should be able to go faster than that. What's the y-intercept? -1. What does that 2 refer to? The leading coefficient. You guys remember the 2 refers to the slope, yeah. So slope of 2 means like go over 1, up 1, over 1, up 1. I got the pattern here. Isn't that much faster than typing in your calculator? That'll do for now. And I'm actually going to not draw a line in right now. Normally we would, but I'm going to avoid the line just because it's going to get really messy otherwise. You guys good with this so far? Okay, if you have another color or another, I don't know, way of doing it, maybe use like dots or X's or triangles maybe to differentiate. Let's do this one right here. x minus 2. Slope of the graph is 1. Y-intercept is negative 2. So here's negative 2. A slope of 1 means you're just going up 1 always. Sense? Okay. Well, when I ask you for f of x plus g of x, what I'm really asking you to do is add their y values to each other. So for the same x value, add their y values. So I'm just going to like draw just like a vertical line right about here. And I'm going to find their y values. See how this guy's y value right here is 3, and this one up here is 9. Well, if I add them, it should be 12. That's off my graph, so I won't worry about that one. So let's try the next one. In this input location, see this input right here? Here's an input that gives you 2. Here's an input that gives you 7. So when you add them, it should be up here at 9. Let me know if I lose you. Here's an input of 1. Here's an input of 5. So when you add them, the inputs added should give you 6. Here's an input of 0 and an input of 3. Sorry, I should say that better. For this input, the output is 0. The output is 3. When you add the 0 and the 3, you get a 3, right? All right. How about this one? Negative 1 and positive 1. 0, yeah. Okay, careful with your integers here. You are adding negative numbers. Negative 1 and negative 2 adds to give negative 3. Doesn't this pattern look like it's starting to give us a straight line again? What would the equation of this line be if I kind of work backwards, just looking at the graph? What's the y-intercept? Negative 3. So this should be y equals with a minus 3 at the end. And then what's the slope look like it is? Like if I go from this point over to that point, it looks like it's over 1 up 3. So just based on this, should the graph be 3x minus 3? Now try this. What if I were to take these equations up here that I started with, and I looked at the algebra there? If I took 2x and I added one more x, 3x. If you took minus 1 and added minus 2, minus 3. Does that make sense? It seems almost silly in a way because like it's exactly like you'd expect it to be, isn't it? Right? Like even if I didn't teach you this, this would hopefully just be logically intuitive, where you'd be like, well, this is what we do with other numbers, this is what we do with other letters, wouldn't this just work with equations in the same sort of way? So it's kind of a nice place to start. All right, so let's try this. Let's sketch the graph of these guys now being subtracted, and let's try to find the equation after we subtract. So let's just take consecutive points. Right? Here, we just need to make sure we do the right number first. This is a minus 3, and then we're going to subtract 1. That makes sense. We have to do the blue graph first before the red one. So minus 3 subtract 1 is going to give us minus 4. Turn off phone. Okay, minus 2 needs to subtract 0. So that's minus 2.
Why do you subtract it?
Sorry, good question if I wasn't clear on that one. Okay, how about here? One of the graphs is minus 1, the other graph is minus 1, and we're subtracting it. Minus 1 minus minus 1. Good, 0, yeah. After a while here, I feel like I've got the pattern. Don't you guys too? Right, so over 1 up 2, over 1 up 2, over 1 up 2, over 1 up 2. This is a linear graph. What's its equation? Y equals slope 2 plus y-intercept
Actually, probably is my wife. She actually really does need to get a hold of me. Hello. Hi. Yeah, I'm in class right now. You need to learn Friday bell times. Okay, what's up? They need the router from downstairs, like above the freezer. Just unplug the whole thing and bring it over. Just above the freezer and the telephone. Okay, bye. Okay. Sorry, guys.
She thinks it's not Friday. She's like, you're at lunch. I'm like, I'm not on lunch. Oh, by the way, I should point out, there is going to be a point sometime in March where I am going to be expecting a phone call when my baby's born. You guys know that I have another kid? I have another kid, by the way. So Melissa's due date is March 23rd. So pretty much any time in March, I'm going to kind of be, on pins and needles if I get a phone call. So anyways, just so you're aware, if all of a sudden I'm like, bye. What was that?
Have your sheets
Okay. Okay. Do you guys feel like you got the hang of this here? Okay. What's the only difference between the one we just did and this one here is that on the last one it was f minus g, and on this one it's g minus f. I think I don't have to do the example to make my point. When you're adding, does it matter which one gets added first? No. But when you're subtracting, does it matter which one goes first? Yes. All right. So just make sure you're aware of that. Okay. Make sure you're aware of on subtracting, the order matters, and adding, the order does not matter. Okay. Let's move to something more challenging then. Now I want to multiply them. Okay. Because obviously add and subtract are fairly straightforward at this point. What happens if I multiply? Okay, so again, for consistent inputs, take the outputs and multiply them. So right here, I've got a 1 and a negative 3 being multiplied. So 1 and negative 3 will give you negative 3. You good? Okay. Okay. All right. For this value here, you've got a 0 and a negative 2 being multiplied. So 0. Here you've got a negative 1 and a negative 1 being multiplied. So positive 1. By the way, just to make sure it's clear, you guys get the idea that you have to keep the same input, right? Like I can't take this guy's x value and then this guy's x value. That's not fair, right? You have to keep the same x value. Okay. Here you've got 0 and negative 2. So 0. What just happened? This isn't a straight line anymore. What's it making? Right. Think about this for a second here. This first one here was linear. Let me give you an example of a linear. This first one would have been x plus 1, right? Because it's got a slope of 1 and the y-intercept is 1. This guy down here would have been negative x minus 3 because it's got a slope of negative 1 with a y-intercept of negative 3. If I asked you to multiply these guys by each other, that's foiling. And doesn't foiling that provide a quadratic? Right? So as we keep going, hopefully this will seem quadratic when we're done. This is 1, this is negative 3, so negative 3. I'm starting to run out of points here, let's just do the last one here. 2 and negative 4 would give negative 8, but hopefully you can see. This is creating us a quadratic. Why is it upside down? The negative leading coefficient. Right? When we multiplied these by each other, see how this guy had a positive leading coefficient? This guy had a negative leading coefficient. When they were multiplied by each other, a positive and a negative would give you a negative, right? If they were both positive, it would have been a right side up parabola. If they were both negative, it would have been a right side up parabola. But if one's positive, one's negative, then it's upside down. You guys get the idea here? So the concept basically being that if we add linear to linear, it'll stay linear because you're not making quadratics out of it. But as soon as you multiply them by each other, then it ups the degree of it. Okay, so let's try another one here. Let's sketch the graph of this one and this one here. But rather than doing it piece by piece like we just did, let's skip a step here. Now that I know that I'm going to be multiplying, by the way, if they're just written next to each other or with a dot, that means multiply. Now that I know that we're multiplying by each other, why don't I just write out the new equation? If this one was a linear one and this one was a linear one and we multiply them, won't the new equation just be negative 2x squared plus 2x? Right, can you guys just boil that in your head, basically? There's our new equation. All right, now if I want to sketch it, let's just do a quick table of values maybe. What if x is 0? 0, 0. Okay, if x is 0, it's 0. You guys do that? What if x is 1? 1 squared is 1 minus 2, so this is minus 2. This guy right here is going to be plus 2. I should 0 again. That's okay. Let's try it being 2. 2 squared would give you 4, times by negative 2 would give you negative 8. If you put a 2 here, that would give you 4. Minus 8 and 4 would give you minus 4. I actually feel like I have enough to know what the graph's going to look like. Do you guys feel like you know what the rough shape of this is going to be now? Which way is the parabola going to go? Right side up or upside up? Okay. Here's your 2 roots. This kind of gives us a clue. It's probably going to do like that there and that there, give or take. No. And unless we really need to look at it into more detail, this is probably a good enough sketch for right now. When I ask you guys to do a sketch, I would ask you to find, like, label these points. This would be at 1 and 0. This would be at 0 and 0. And we got the rough idea, right? So linear times linear gives you quadratic. Sound good? Okay, so here's some more notation again. You could write them literally next to each other, or another option is you can write f dot gx as a way of multiplying. So if you ever see this notation, it just means multiply them to each other. Again, when you do division though, division you gotta be careful, because like subtraction, order matters. So if you do a plus b or b plus a, it doesn't really matter. Right? If you do a times b times a, doesn't really matter. But for add, for divide and subtract, you know what I'm saying here? You gotta know which one goes on top. So the little note I've thrown down here is the bottom of the fraction, by the way, can't ever be 0. So whichever one goes on the bottom, make sure that it doesn't somehow have a 0 in it. Okay, so let's try this in a different method now. Rather than focusing on this in a graphical format, let's just focus on it as an equation instead then. So let's say I give you some equations. Let's find the new functions that are made in these scenarios. So for the first one, this notation here is a fancy way of saying multiply them by each other. So FOIL. Here's how I would do that. Then I'd go like x times x squared to give you x to the 3. 4x times x gives you 4x squared. 3 times x gives you 3x. One of the methods I like when you start foiling things to the power of 3, 4, and 5 is once you don't have to do like one column, but then you like switch to the next number. I like to stack like terms underneath each other. So when I do this next set here where I do like say x squared by minus 2, I'm going to put it right here. Just because it's like right next to the other x squareds. Does that make sense? It's a trick I use myself. So then when you do 4x times minus 2 and you get minus 8x, I'll put it right there. And when you do 3 times minus 2 to get minus 6, I'm going to put it like in that column there. Does that make sense? Like the other option you have, not that it matters, but like you could take all this stuff and like write it next to it there. You know what I mean? Just the reason why I like writing it down here is that now it's really easy for me to combine the like terms. And I promise you, when you guys are getting to the power of 4, 5, something like that, you're going to have so many like terms to combine. So it's good to have an organizational scheme. So final answer is x to the 3 plus 2x squared minus 5x minus 6. Doesn't that make sense, though, that a quadratic times by a linear should then bump up to the next level and become cubic? Does that logic make sense? Okay, for the next one, though, dividing, we got to make sure we know which one goes on top. I'm doing both to illustrate a point. You can do f over g or g over f. So let's write one out here. F would be x squared plus 4x plus 3 over x minus 2. What have we done? Like, sometimes there's actually not a lot of tricks to it, right? That's all I've got. I should point out, you should check to see whether you can factor. You actually can factor this guy. It could be x plus 1, x plus 3. You know how I like that thing factors? The only reason why it's not useful, though, is that the x minus 2 on the bottom doesn't actually cancel anything. Because if you could have canceled, you would. But since you can't, we're kind of stuck. So you may as well just leave it here. Whereas for this one, when you divide, all you do, you just flip it the other way. There you go. That's all there is to this one. If there's nothing else I can do, I could try to factor, but nothing cancels. So. Sound good? Okay, one last thought. Based on the way, the order that I'm teaching curriculum here, I'm actually taking this lesson, and it's actually like one of the last lessons in your textbook. And I've found that it's actually one of the best ones to put first. But it just causes one issue. We have not talked about what this graph looks like yet. We're going to in our second unit on non-polynomial functions, because this now is no longer considered polynomial. As soon as you make it into a fraction and the fraction can't reduce, this is known as a rational. You know that word rational? And by virtue of being a rational function, it's technically not polynomial, so I will not be asking you to graph this yet. We will, just not yet. So we will learn how to graph this later. Okay. But so long as it's linear, quadratic, cubic, quartic, I would expect you to graph that. So we'll circle back to this in a second here. Sound good? Okay. So that's actually what my next slide here talks about. When you combine functions, they become other function types, right? So, I mean, they could be polynomial, but we're going to learn about all sorts of different types here. So here's linear, here's constant. This, by the way, is not even a function. Why? Why can't this be a function? What does it fail? The vertical line test. Right? Because it is a vertical line. So here's quadratic. These, by the way, we're going to learn about these in our next unit, exponential and logarithmic, but you know, they're just more graph types. Okay, for this one right here, you know how I just told you though a second ago that we weren't going to be graphing ones that divide? That only is going to be the case if it doesn't reduce though. Watch this. If I were to take f over g, see how this guy right here, it can actually be factored to x plus 7, x plus 2, right? Because we need numbers that add to give 9, which is 7 and 2. We need numbers that multiply to give 14, which is 7 and 2. If I were to write it out, you could write it then out as x plus 7 bracket x plus 2 over x plus 2. Do you guys see now, though, how in this case here, the x plus 2's will cancel? What are you left with? Well, you're left with x plus 7. Now, can we graph this? Yeah. Okay. X plus 7 has a y-intercept of 1, 2, 3, 4, 5, 6, 7. Slope of 1. Yeah, close enough. All right, that was easy, wasn't it? So the point I want to make here is that if it doesn't reduce, it's considered rational. We will get to that in an entire unit on non-polynomials. But if it does factor and cancel, well, then it's back to being linear. Which, doesn't that kind of make sense? If you have a quadratic, which is the power of 2, right, and you divide it by a linear, which is the power of 1, aren't you essentially like removing one of the factors, leaving you one left, the one left being linear? Okay, there's one more thing I have to show you though, and this is really meant to be in the non-polynomial unit, but I'm going to show you it now just because this is the way it actually is. I won't test you on this though. You know how you can't have the bottom of a fraction be 0? We have a name for that. We call it a non-permissible value. Have I used that word before with you guys? Non-permissible value? Okay, let's write this out down here. Non-permissible value. I don't think I really need to define it because doesn't the words kind of make sense? It's a value you cannot use. We usually abbreviate it to MPV. What is the one value that you cannot use in your domain?
Please excuse the interruption. We have a lost iPhone 5C, a white one. If you know where this iPhone is, please bring it to the office.
There's one value for X you can't use, and it's -2. Why would -2 not be valid? Well, you know how way back here I canceled this? But in the step before I canceled it, right here, if I tried to put a -2 in right there, wouldn't that give you a 0 on the bottom of the fraction? And isn't that not allowed in math terms? So I know you were canceling, right? Which is fine, it made it linear, but it made it linear with one exception. You can't use -2 because before you canceled, -2 wasn't allowed. So it actually creates what's called a hole in the graph. We'll talk about this in the next unit, so don't freak out. I'm not assessing you on this, but I want to make sure that I'm not like teaching you something incorrect. What this means then, if I ever asked you for the domain of the graph would not be x is an element of the reals, because there's actually an addendum to it. You would say x can never be -2. If you tried to make x be -2, it wouldn't work. Let me show you. We'll use the graphing calculator now. Let's say I typed in the original, which was x squared plus 9x plus 14. Just let's make a bracket around it. And you divided it by x plus 2. Okay, so look at the graph. The graph looks like a good old linear graph, right? It doesn't look out of place, except what if you go to the table of values? Look at this. Everything going up looks normal, right? It's all good. Every input gives an output. But if I go backwards to -2, all of a sudden there's an error there. We will talk about this more in detail, but I just need you guys to be aware that it doesn't officially make it a linear graph. It makes it a linear graph with a hole in the graph. Does that make sense, Lo? So, long and short of it is to notate it properly, what you would do is at -2, you would put a circle. That's the notation we use. And a circle indicates that you're not allowed to use that value. It's kind of like, I don't know, when I teach Kinsey M, that, you know, you're allowed to do this, you're not allowed to do this. This is her one. Kinsey, you may not touch the stove. You can play with anything else in the kitchen today, but you can't touch the stove. I don't know, a weird example, right? The whole basically means this is the non-permissible value. But don't stress over that right now. Just, if it does divide, then just sketch the graph. Sound good? Cool. Okay, that's basically what my next slides then are talking about, is where I kind of went ahead here. So the denominator of a fraction can never equal 0. You guys know the idea of an asymptote from last year? Do you remember that word? You know what? Don't freak out over it right now, because I will go over it again later. But asymptotes are basically values you cannot use. Like x cannot be 5 for whatever reason. Like if I give you the graph 1 over x minus 5, the one thing x cannot be is 5. Right? That same sort of logic applies here. Look at this graph. What's the one thing that x couldn't be? 1, right? See how they did a little open circle right here? Just indicating that that's the one thing you can't use. When you do factor this and cancel as the difference of squares, sure, it does cancel, leaving you with x plus 1. That is the graph of x plus 1, just with an exception. Don't touch the 1. Okay, let's skip over this one. Okay, here's a slide just kind of talking about when dividing polynomials, unless they divide evenly, it won't be a polynomial. So like say take this one right here. I can try to factor this guy. This would be x plus 5, x minus 4, x minus 6, x plus 3. Is this going to be useful to us in the polynomial section? No, because it didn't actually cancel. Does that make sense? So we'll get to it though. So this is next year. That being said, even though I won't make you do it like sketching a graph of it, I could expect you to take individual points again though, and use the points to divide. That could still be valid. So we could still go back and do this task. Let's do f divided by g on the graph like this, and see how that turns out. So f right here is -3. We're dividing by 1. So -3 divided by 1 is still -3. Here, we've got -2. We're supposed to divide by 0. Can you do that? This is going to cause some sort of error. So I've got to just leave that blank. This cannot exist at this point here. So, -1 divided by -1. Positive 1. Okay, this next one here is still valid. Can you take 0 and divide by -2? That's okay. You can go 0 divided by a number, it's 0. What are we up to? This is 1 divided by -3. 1 divided by -3. Isn't that -1/3? I don't know. It's going to go somewhere around here. 2 divided by -4. To -1/2. 3 is dividing by -5. -3/5 is about 0.6, so it's getting like a little bit bigger. Does this graph look familiar to you? I wouldn't expect it to, right? It's got some sort of weird little thing going on right here, but then there was like a point over here. There was a hole right here. So we will cover the graphs later, but what I still might ask you to do though is still divide individual points. Does that make sense? Okay, let me show you your assignment now, because we can do some questions.
Cody Hagan, can you please come to the office? Cody
Good
Hagan,
shit.
please come to the office.
Did that go too fast, or are you guys able to follow that? You're good? Okay, let's talk about how to do some of these questions now, because you can actually do a lot of them. So here's the first question. It's kind of like when we were using the graph, only now it's a table of values. Give me a second. Find it first. If I were to ask you to do f minus gx, all I'm asking you to do is take the f value and subtract the g value. So for when x is 0, what would the subtracting one give you? 1. So here's how I kind of expect you to write this, just so you guys kind of know how the answer key would be written out. I should do the first one with you. Take a snapshot. So like if I were to ask you for A, if 0 is your input, when you take 2 and you subtract 1, you end up with 1. What if 1 is your input? So if 1 is your input, what would the second number be of this set? Take a stab at it. See it? Yeah, because 5 minus 4 would also give you 1. Let me skip ahead to a different one just because they're not all 1. What if 4 was your input? What would the second number in like the ordered pair be? -5, yeah, because 0 minus 5 would give you -5. Does that make sense? Now I did skip 2 and 3, right? So you still have to do 2 and 3. Don't skip any of them. Does that make sense? Kind of how this would get written. Let me try another one here. B. I want you to divide them. So start with 0. If 0 is your input and you divide these two numbers from each other, what's your output? You're right. That's it. You guys got to come back to being quiet again. What about if 1 is your input? If 1 is your input and you divide these, what do you get? That'll work. Or if you don't want to do 1.25, you could just say 5/4. I'm cool with that. Okay, one more, then I'm going to pause here. What if 2 is your input? You can't. Okay, the reason why I want to point this one out is that if you cannot put a number there, like if this cannot occur, we don't bother writing at all. Does that make sense? So don't write like 2, x or something like that, or 2, error, because if 2 is apparently an invalid number to plug in. You know how back in my notes a little while ago here I was talking about how there's certain numbers that you couldn't use, like right here there's this hole in the graph because x couldn't be 1. Well, apparently, based on how this particular function here works, you can't use 2. If you try to use 2 as your input, it gives you a non-valid answer. Okay, that makes sense at all? Okay. When you guys get down to C, you're going to have to hold off on C because tomorrow, or I guess Monday, I'll talk with you guys about how you do multiple sets of brackets. It's actually next day's topic. So maybe hold off on C. Okay, that multiple sets of bracket thing also means that you're going to want to hold off on doing number 3. You guys should be able to do number 2, though. So number 2 basically says f of x is x plus 2. And then an f plus g is going to give you x squared plus 5x plus 6. I'm going to want you to graph those in different colors and then figure out the missing portion for g so that when you take this and you add it to this, it gives you that one. You guys get what I'm saying here? Okay. This plus what would give you that one. And then sketch all 3 on a graph in different colors. Hold off on 3, because if you ever see this notation where there's like F bracket, G bracket, like all those bracket stuff, that's Monday. So we'll do that later. You guys should be able to do A and B here, because it's kind of similar to what you did here. Let's talk through A here. If I did F minus G of X, this means subtract them, right? But you have to subtract the Y values, not the X values. So find a consistent Y value. See how there's a 1 right here for X and a 1 right here for X? I can subtract their Y values. So this 1 and this 1, I could then subtract the Y values and make it 1 minus 2 for negative 1. This guy's got a 0 to start with. Is there a guy over here that has a 0 to start with, though? Okay, so if one of the functions has a point, but the other one does not have one, you can't add them together. You can't add something to something that doesn't exist. You're not adding something to nothing. You're adding something to something that's not even there. Does that make sense? So like for this next one right here, when you subtract them, I'd expect you to have one that goes 1 comma something. I'd expect you to have something that goes 2 comma something. You see how there's a 2 for this one and a 2 for that one? I'd even expect you to have one that goes 3 comma something. But I would not expect you to have something that goes 0 comma something, because although that one has a 0 to begin with, since this one doesn't, you can't put it together. Does that make sense? Okay. Why don't I leave that there for now? That should give you something to work on in the meantime. We'll pick this up again Monday. Sound good?
Cash yellowing, can you please come to the office?
If I have your form, so
Cash
the Scorpio on there, you are free to go.
yellowing.
Or you could just stick around and work on the first few questions. Sound good? Okay.